Though we know who we are, yet we know not what we may be. So maybe I'm the one, or maybe I'm crazy. I'm from.
Welcome back to your Nomalarchy Guide to Machine Learning. My name is Kalu, and in our last video, we were able to get our correlation because we need the correlation between we need a lot of correlation. So we got the correlation between our first independent variable and our y, our target variable. So we got the correlation between our ground living area and our price, our y variable. So now we want to do the same thing, but just like we did with standard deviation, we want to write our own get correlation function. We want to abstract away all these complicated code, all these details that we calculated in order to get the correlation. We want to abstract that away into our own created function that's just going to automatically do that for us for any two set of observations that we want to get the correlation of. So in order to do this, we're just going to do the same thing that we did above here, initialize an empty list, go through that empty list and get the errors products list, sum that list up, then get this bottom part, right, which is the products of the standard deviations. Once we do the errors product sum, divided this right here, divided by the product of the deviations, then we take that, which we call the right side of the equation, and we divide it by, we get which we call the right side of the equation, and we divide it by n minus 1. Again, n is the total number of observation, and that gives us our correlation. We want to do all of that inside of a function. We want to abstract away those details, hide away those details into our own self-created function. It's going to work just like NumPy's correlation coefficient function that can give you a correlation given two sets of observations. So why don't we get started with creating that own function? So we're going to call that function get, and I assume you still have your terminal up, so you still have access to all these variables like area and price and other things. So, and also we're going to need this get standard deviation method that we created earlier. So this get standard deviation function that we can give it any set of observations and it'll get the standard deviation for that. So we need this function that we did earlier. So now that we have all that, why don't we get started writing our function? So we're going to call this get correlation, and it's going to take x and a y set of observation. This is a set of observations. That's why I made it capital. So the first thing we want to do, just like we did before, we want to go ahead and let me show you guys right here. Where is it? So we want to initialize this empty list called error products. Why don't we call that error products list? And we want to initialize that empty list and loop through all sets of observations for area and all sets of observations for price. Loop through this at the same time, get the error, which is the error products, I should say, which is the product of the error, the difference between the observation, the observed area minus the average area, times the corresponding observed price minus the price average. And we want to append that to this error products list we have. Again, just like we did before in the previous video with writing the function to get the standard deviation, we can do all of this 1, 2, 3, 4 lines of code, initialize an empty list, loop through that list. We can do that in one line of code using a list comprehension. So why don't we go ahead and get that done? So this is where we're typing code. So we want to get our error products list, and instead of doing this where we initialize an empty list, write a for loop, we're going to do that all in one line of code, and I'm going to show you guys how to do that. So first thing we need is this right here. So let me show you guys, go back up to our for loop. This is what we wrote earlier in the last video. We need to get this right here, which is for each observation, we need to get this. So we'll just write it ourselves. So for each observation, this is our x, this is our y. So for observed x, so I'm sorry, we should do observed x minus x dot mean, right? And then we must multiply that with observed y minus y dot mean, the average y right here. And we want to do that for each x zip x y we want to do that for each observed x, observed y in zip x.y. And then why don't we go ahead and close our list comprehension, and that should be good. We have our errors products list. So next we have this, but we want to get the sum of it. So why don't we get error products sum equals just the sum of that list that we just created. And there it is. Next we want to get this denominator right here for the right side of the equation, and that is just the standard deviation of our x times the standard deviation of our y. So we can use this get std method that we have here that we just created above, or we can just use panda's built-in std method. So just get std function, or the built-in std method that pandas provides. So why don't we use the built-in one? So we need to get standard deviation, x standard deviation equals x.std, and then y standard deviation equals y, capital Y again. This is capital X, capital Y, because we wrote a capital X, capital Y up here. So good. Now we need to get these products. So standard deviation products equals x times x std times y standard deviation. So great, we have this products. Now we need to take, we have the sums, right? This is here. We need to divide it by this product. So why don't we go ahead and why don't we go ahead and do that right now? So, and let's call that the right side of this equation. So the right side of this equation is going to be, equal to the sum of the products of the error products. So error products sum divided by the products of the standard deviation. So standard deviations products. And that is going to give us the right side of our equation. We want to take that and multiply it by n minus 1. Multiply it by 1 over n minus 1, which is the same thing as dividing by n minus 1. So why don't we go ahead and say our correlation equals right side of the equation divided by n minus 1. Now what is n? N is just the number of observations. So number of observations, same thing as x. We could do y as well, but let's just do x dot counts minus 1. And that should give us our correlation. And then at the end, we could return correlation right there. So that should be our function. Let's try it out. Get correlation, and we need to give it a set of x observations, so let's give it our area, and a set of y observations, let's give it our price. And it should print out, there it is, 0.70. That is a strong correlation. And again, we can use NumPy, so from import NumPy as NP. We can use NumPy's built-in correlation coefficient to get the Pearson correlation, and that should be the exact same thing that we got right here, 0.70862. That's the exact same thing, 0.70862. That's the exact same thing we got with our self-created method. So congratulations, guys. We've done a lot. Why don't we get the correlation now of, why don't we try just with the garage, or the garage area, G area. And if you guys forgot, we have this garage area right here. So why don't we get the correlation of garage area and price? And just to prove that our method works just as well, we can get correlation in garage area and price. So great, and let's get the correlation for, again, just to compare it, for area and price. And why don't we lastly get the correlation for area and garage area? So there are our 3 sets of correlations. We've done a great job. I'll see you guys at the next video where we go back to get in this. Where are we? We go back to figuring out how we calculate this coefficient for our first independent variable. And as you know, this is important for figuring out the formula for our regression line. So you guys have done a good job. Again, please like this video if you enjoyed this content. Share it to at least 10 or 20 of your friends. Subscribe, and if you're African, you gotta subscribe. You gotta share it to at least 100 to 500 of your friends. So thank you again for watching this video. In the next video, we're gonna continue figuring out this formula, which requires that we go to this right here, how to calculate a coefficient. So we're going to calculate the coefficient for our first independent variable, and that is ground living area. So see you guys at the next video. Then again, don't forget to like, subscribe, and share. Peace.
Financial freedom, my only hope.